All right, guys. What's up, guys? Mike the Coder here. So last video we actually solved the problem way too fast. Yeah, I ended up solving the problem game way too fast. Yeah, so that's why I created another video. I don't feel like doing two problems in one video because that's just strange. Yeah, it's kind of tried that with like hacker rank, and that made people kind of upset in the comment section. So that's why. Also, it doesn't really make much sense with the title, because then you can't even search for the problem. But anyway, so yeah, I started another live stream going over another problem. The last live stream we solved in 10 minutes, which is game. I'm doing a bunch of ad hoc problems right now because a lot of Codeforces problems are now ad hoc. So these are problems that don't require algorithm knowledge, but they just require you to figure out an observation. So figure out an observation or find the pattern. That's what most of these problems are like. So yeah, that's what ad hoc problems are. So now I'm gonna do song compression, which is another ad hoc problem. Okay, so I'm actually gonna let's see if after song compression, what are we gonna do? We're gonna do Olympiad. I don't know. All right. Songs compression. You have n songs. The size of the ith song is AI bytes. You have a flash drive at most m bytes in total. Initial this drive is empty. You want to copy n songs to the flash drive. You can compress the song. If you compress the ith song, the ith size of the ith song reduces from AI to BI. Okay. You compress any of the subset of the songs and copy all songs to the flash drive if the sum of their size is at most m. You can compress any subset of the songs, not necessarily contiguous. Okay, so I could just pick any of the values and then reduce it. You want to find the minimum number of songs you need to compress in such a way that all the songs fit on the drive. The sum of their drive is less than or equal to m. Okay, so the minimum number of songs need to compress in such a way that all the songs fit on the drive. We have A2, the size of the initial size of the ith song after the compression. Okay, so what do we have? We have n and m. N. Okay, so. Okay. Okay, so I have an idea how to do this. Let's just actually read in the input sizes first, but we probably have to do a sorting again. But Vishal, is there any coding practice? Is there in your platform any coding practice course available? This isn't my coding platform. This is it's a code drill tool. So on if you go to code drills and go code drills and you type in your handle on your Codeforces account, it tells you the problems that you need to solve in order to improve your ranking. So that's what it does. Like based on my current ranking, it tells me the problems I need to solve based on it. But in terms of like course, I don't think there's a course about it. Coding practice course available. Yeah, Vishal, I don't know about that. I don't think they have a coding course. But I don't really have a course in general. But I could give more tutorials on how to solve problems, and I could just give more ideas about how to solve problems. And I could go over some more algorithms. But there's not really like a course you could use to solve these problems, if you know what I mean. Like if for ad hoc problems, the ones I'm solving right now, these problems just require you an observation. Like they just require you to be, I don't know, find the pattern or find the observation. Like these aren't algorithm problems. Like there's no standard solution to them. So yeah. Anyway, back to the song compression. So basically, we need to pick some songs. We want to compress some songs, and we want to pick the minimum number of songs needed to compress them. And their sum of their size has to be less than or equal to m. Okay, so if we want to pick the minimum number of songs we need to compress, then that means that we want to maximize the size of each song, right? Yeah, we want to maximize the size of each song. We pick the max because that will, if we want to minimize the number of songs, right? Because, okay, yeah. So, like, if I have a bunch of songs and I want to, let's say I have a bunch of songs and I want to put them into, like, a sack, right? If I want to minimize the number of songs needed to put into the sack, Minimize the number of songs you need. So that means for each song, I want to pick the maximum size, right? So each song, I have to pick the maximum size. So I'm thinking about maybe we could sort by maximum by size, then pick those. So that's what I think. I'm not 100% sure though. So let's actually read that in first. Okay. So we have then, what do we have? So we have N and M. So we'll read those in. And then for each line, we read in AI and BI. So that means we'll read in a pair. Okay, so I have I'll call pair data. Okay, so I have a bunch of arrays. I have an array of pairs here, and then I have N and M. So I need to put M. Okay, so these are just a bunch of variables that I realized from solving previous problems. A lot of the variables are kind of similar, so I just grouped them all like this. So I'm going to use those variables. Okay, so here I'm created a array, created variable N and M, so I'm going to read that in. Oh yeah, so now I need to create the size of my pair. So here, what did I say? Data is equal to vector pair. LL is just like long. And why can't I do this? Data is ambiguous. No, I put data here though. Data is right here. Something's wrong with my compiler. Data is literally right here. Is there another data? Data is ambiguous. Okay, okay, let's use like, I don't know. We could use like, we use D. Okay, I'll get rid of D here. Okay, now that works. That's really weird. Okay, yeah. So once we read then that, let's read in A and B, which are just integers, and then let's push it into the, we'll push it into our, yeah, okay, so read in A, B. I think I have those as variables, yeah, and then now we're just gonna push these as pairs into our array. Well, actually, we could just say, yeah, like that. Make pair B, AB. Okay, so that's just a pair for each values of my array, and then I call solved. So now in solved, I'm going to do this in solved. So I have a function of solved. Okay. Now let's see. Oh wait, we don't. Yeah. Okay. Okay. So now, okay. So we want to pick. What do you want to pick? We can hold at most M bytes in total such that the flash drive is empty. You want to copy all M songs to the flash drive. You can compress the songs. If you compress the ith song, the size of the ith song reduces from AI to BI. You can compress any number of subset of songs and copy all songs to the flash drive if the sum of their sizes is at most M. You want to find the minimum number of songs he needs to compress in such a way that all songs fit on the drive. In such a way that all his songs fit on. Oh, crap. The sum of all his sizes is less than or equal to M. All of the songs fit on the drive. If it's impossible to copy them, I'll print -1. Otherwise, print the minimum number of songs. Okay. Sort by... okay. Wait, minimum number of songs he needs to compress. Minimum number of songs. Okay, so let's sort by the initial sizes. So AI is the initial sizes, right? BI is the song to reduce. So let's sort by greatest to least. And the reason why we sort by greatest to least is because if I want a minimum number of songs to compress, then that means I want the maximum size of each song. So I'll try that. Hi, vibe have Vibe have. How you doing? Vibe have. Is that how you pronounce your name? Vibe have. But anyway, yeah. Let's do this problem. Okay, so back to this. Yeah, let's back to this. I'm gonna push this chat outside. Maybe I should actually like have a separate chat in order to when I live stream, so then I don't have to keep going back and forth. Because like if I don't know, so I get two computers to read the chat. I don't feel like exposing your guys' names like that. But yeah, okay. So I'm gonna sort by greatest to least. So I'm gonna do sort D begin, sort D dot end, and I'm gonna use greater to least. So now so when you do sort by pairs, it sorts by the first value first. So now we're gonna have a bunch of large values. Okay, so let's actually go over test case. So we have 21. So M is 21, so we have 21 here. And then what do we have? We have 10, 8, 10, 8, 7, 4, 3, 1, 5, 4. 7, 4, 3, 1, and then what is it? 5, 4. Okay, so if you were to sort by greatest to least, it would be 5, 4, and then 3, 1. So let's actually do that instead. 5, 4, and then 3, 1. Okay, just to make it consistent. Okay, in the first exam, we compressed the first and third songs after these moves. The sum will be equal to 8 plus 7 plus 1 plus 5 plus 8 plus 7 plus 1 plus 5. 21 is less than or equal to 21. So Ivan can compress the first and second songs. Okay. Another thing, we could brute force through all possible subsets and just compress every song. We could do that. How many? Okay, the constraints are not. The constraints are pretty big actually. So you can't just brute force it. I don't know. We'll see. Okay, so if you were to sort by greatest to least, let's see what we could do here. Sort by greatest to least, what could we do here? So we have two integers, okay, so now let's look at, so 21 is our initial thing, right? So what did he compress first? So you first compress the first one. So you compress 10 because it's too large, right? So I compress 10. So now it's 8. So we have 8 first. Did you compress 7 to 4? He did not compress 7 to 4. Okay, so he kept 7. That's weird. Okay, so he kept 7. Okay, so he picked 8. He picked 7. Why didn't you compress 7? Minimum number to compress. Okay. He picked 1, okay, and then he picked, we compressed 5. Oh, he compressed 3, okay, so he compressed 3. Okay, so you compressed 3, so you did this. So pick 1, and then he picked 5? Why did he pick 5? So this would get you 15, 2 plus 1 plus 5, which gets you 21. Sure, okay, that makes sense. Technically, why can't you just compress? Oh, because we want a minimum number of values to compress. Oh, we could take the absolute difference. We could take the difference of these two. So then that's like 2. This is 3. This is 1. This is 2. Oh, but then that's 2. That's not compressing. Okay. I'm thinking about going through every subset. And just try out all the values. Let's see if that works though. Okay. So technically we don't even have to sort, but if you go through every possible subset, so it's 8, 7, 2, 4, 17, 7, 4, 2. So go through every possible subset, and then just pick the values to compress. And if your values are, if the number you pick to compress is less than or equal to 21, then you say yes. Otherwise, you say no. That's what I'm thinking. But okay, let's try it. Let's go through. Okay, so go through every possible subset. Okay, 4 in J, 0, 0, S, M, J, not M. Crap. N, J plus plus. If I and by J is greater than 1 shift F by J. I think that's what it is. I keep forgetting what this is. 1 shift. Is it shift left? Shift right. Yeah, okay, I think it's shift right. Pretty sure this is shift right. Hold up. Yeah, I'm pretty sure it is shift right. So let's go through every possible subset. Let's add every value into our subset. So let's call I don't know, D. I don't know, val. Val dot pushback D add J. Why can't I do that? Oh, it's a pair. Dang. Let's do pair. Okay, so you go through all the possible subsets. Okay, and now what you want to do is you want to pick the right value. So we're gonna sum up the right value. So we need like a variable for like lowest. What was it? Minimum. What was it? Minimum number of songs. Yeah, that's what we need. We need to find the minimum number of songs. But I feel like it's like minimum number of songs to compress. Like, okay, you go through every possible subset. You pick the song to compress. Right? Does that mean you're going to compress all the songs? No, I know. I don't know, actually. So here, what we're going to do is that this is like sum of each subset. So plus equal to d at j dot second. So this is going to compress it. After you sum it up, if it's less than or equal to, we have to, here's the problem, is that the rest of the values that you're not picking, you need to sum those also. So if you go through, okay, hold up. So like, okay, so let's go back to this. So like, there's 4 values here, right? If I pick every subset to sum right here, the other values that I'm not summing, I need to make sure those are, I don't include those. So like if I, okay, so if I pick 8 is a subset I'm summing, and then 7, 5, I don't pick those. So here they pick 1, right? They compress 3, they pick 1 instead of 3. So if I pick 8 and 1, the other values, I need to pick those that I don't pick though. That's not in it. So for those values, I need to, what I could do is I could could sum up all the values initially, and the values that so like here I could sum up all the values initially. So I have 10, 7, 5, 3. So I add them up in a total sum. Then whichever value that I'm compressing, I pick that and I just subtract the jth value from it, from the total sum, and then I add this value instead. So I think that would work. Yeah, so I could do that. So here in the beginning, I'm going to sum. Okay, so actually, I'm going to create a global variable called total sum. Total S. Total S. Okay, that's going to equal to 0. What is the problem? I have a problem. I have a compiler error. Oh, here. Let's remove this. Okay. Yeah, so yeah, okay. So we have total sum. Here total sum, total S is going to plus equal to A, because it's going to be all of the initial values of this, right? So now when I pick a subset, go through every subset. When I pick a subset, I'm going to take total sum and subtract by d of j dot first. Then the sum, I don't need sum. Ah, crap. I don't want total sum to be changed every time. I'll tell you what. Okay, I'll pass it in. Okay, I'm not going to use a global variable. Let's get rid of total sum. Total sum is going to equal to the initial value. So here I'm going to make it a it's going to be a variable here that add up, and then I'm going to pass total sum in here. Okay, so there, and then where's my solved? Okay, so I'm not going to change total sum. Okay, so when I pass it in, total sum gets subtracted by first, and then I add up total sum plus equal j add something. Okay, so now, oh crap. Okay, so sum is going to equal the total sum. Sum minus equal sum. Okay, yeah, so I'm resetting sum every time to equal the total sum whenever I pick a value in the subset. Okay, right, yeah, so then I subtract and I have sum. Okay, now if sum is less than or equal to m, then that's fine, right? Then I need to pick, so they want the minimum, what do they want? The minimum number of songs he needs to compress in such a way that all the songs fit on the device. Minimum number of songs. Okay, so that means we just take the minimum of the size that we add for each subset. Okay, I hope you guys are following along. So we just take the size. Okay, if sum is less than or equal to m, so let's create a smallest size is going to be equal to the maximum size actually, and then each time we do it, we're going to do smallest size is going to equal to min of val.size. So our each subset val.size that we pushed back, and smallest size. Well, why is this wrong? Oh, size t. Okay, let's convert this to long. Okay, all right. Then after this is done, we just check if smallest size is equal to long max. That means it didn't change, then we print out -1. Otherwise we print out smallest size. Okay, I think this would work because we're just brute forcing every subset and picking the values that we want to in our list. What is the error? Total S is undefined. Oh, total sum. Okay, let's see if this works. So it should give us 2. Gives us -1. So we never reached 21? Are they serious? Okay, wait, let's see. Go through every possible subset. I want to make sure that my thing is correct. Pretty sure what I did was correct though. Go to the end and then go through every possible subset. Oh, what the? Oh boy. Why did it bring me to Code Chef? Maybe I should do like the recent Code Chef challenge. See if that would garner some more views, because I need get some views. Bit masking DP. Counting number of ways to assign a cap to every person. I don't know what the hell that means. We'll just go through every mask. Stop. Oh, what the hell? Looping over bitmask, is this what it is? That's not what I want. I'm pretty sure I literally coded this before. I don't know how I'm like not. How am I not getting this? Yeah, this one. Oh, yeah, this is correct. 0 to end, 0 to 2n. I shift right by j, and by 1. Yeah, that's correct. I shift right by j and by 1. Oh, wait, I shift right by j. Yeah. Oh, I shift left by j. Wait. 1 shift left by j. Oh. Oh, it's this. Okay, that makes more sense. Yeah, I'm shifting left by. Okay. Okay, let's see. Let's see if I do it right. 2. Oh, it's not. It is not copying. Jeez Louise. Oh, yeah, now we got it. Okay, so 2 is right. Let's look at this. This one should be -1. Negative. Okay, so that's right. So now let's actually just submit this and see if we get it right. It's more brute force. Wrong answer on 3. How? We're just brute forcing though. I shift left by 1. IJ. 1 shift left by n. Two to the I. 1 shift left by n. Wait, if 1 shift left by n is. Hold up. 2 to the I. One shift left by n. I can't tell if it's shift left or shift right. Shift left is 2 to the I, right? Yeah. Shifting left is 2 to the n. Yeah, so that's correct. What am I getting wrong for larger values? All right, I'm gonna look at the cases because shift is too large. Oh. Jeez Louise. Huh. Oh. Oh, shift is too large. Okay, so we can't just go through every subset. Okay, well now we have to think more. What do you guys think? What do you guys think? Any guys thinking? Maintain the smooth outlet. Okay. Okay. Well, it's already been 30 minutes for me. Wow. That must have been. Time flies by when you're having fun. It's like you guys watch Eli the Computer Guy? He has a lot of fun. Eli the Computer Guy. It's pretty fun. Anyhow, let's go back to the problem. So you can't just go through every single subset, because that'd be too large. What if we just picked what if we picked all the crap. Oh no, what if we just pick, instead of going through every possible, we just only pick 1, 2, 3, 4. We just go through oh wait. No, you can't just pick one. Okay, we have 21. Let's subtract 10, which is get 11. Subtract 7. Okay, let's actually go through. Which contributes to 21 the most? Okay, so we have, I don't know why. Why did I just erase that? Okay, we have 10, 8, 7, 4, 3, 1, 5, 4. And we have 21, right? Okay, what could I do? So I could compress all of them, so then I would just get 12 plus 1 plus 4. And that's 17. So I could do that. What if you compare the absolute difference? So if you have the 7, 4, right? You sort by absolute difference. So 7, 4. Absolute difference is 3. So 3 is like very large, right? So instead I'll pick 4 here. This is absolute difference of 2. This is absolute difference of 2. This is absolute difference of 1. Okay, so if we sort by differences. Okay, so I sort by largest value of A, and then I sort by absolute differences, B. So then I would have 10. Okay, so what I would have supposed to have is 7, 4, right? Because the absolute difference is 3. 10, 8, 3, 1, right? Because the absolute difference is 2, and then 5, 4, right? And then from here on out, since this is the largest, we pick this. We compress this one, so we compress it. So this is going to be 4. If this one absolute difference is also very large. So not just absolute difference. This number is also very large. So we just pick 8. So then now what we're going to have is just 4 plus 8. And then we add the rest. So plus 1 plus 4. So then the answer would just be 12 plus 1, 17. 12 plus 3, 13. Yeah, 17. No. It would be 12 plus 8, 20. So this is going to be 12 plus 3 plus 5, which is going to be 20. Okay. So sort by absolute difference of the pairs, and then pick for each of those. Yeah. Oh, we also should check if the total sum initially, so like if all the values on the sum of all these values, if they're already less than m, less than 21, then we just print 0. So that's a good test case. So we could do that. But yeah. No one's saying anything in the chat. I guess, am I just watching myself then at this point? Oh, I have 5 concurrent viewers. Yay. Do I have something? Any viewers here? Any viewers? Say something in the chat. Please. Come on. Anyone want to say something? Hi. Bath. Is that how you pronounce it? Bath. Anyone want to say something? Please? Anyone want to say something in the chat? I mean, more than takers. Anyone? 6. We got 6 people. This is amazing. This is amazing. I feel good. If we could hit like just 10 people watching, I'd be so happy. You know, just 10 people. And I've never had 6 people watching. That's amazing, man. 6 people watching. Hit an all-time record, guys. Hope it's not just me though. Okay. So okay, so back to what we're doing. Okay, if total sum is already less than or equal to m, then we just print out 0 because we don't need to do anything. Otherwise, that's actually just called solved. Solve past and total sum. Okay. All right. So we are going to sort by. We need to pass in a comparator. So let's actually create a comparator. Compare diff. All right. This is going to be pair first. No, not first. Current. 1, 2. Okay. Okay, that's less. Okay, for greater, it's compared 2 dot first. No, 1 dot 1 dot first is less than 2 dot first. I think that's greater, if I recall. I think that's greater. I could be wrong though. So let's actually try this pass and compare diff in here. All right, so here, all right, I'm gonna get rid of the subsets because these are too big, so we can't do this anymore. N is too large. Okay, compare diff. Why can't I do this? Oh, comp diff. Okay. Now after this, let's just, I don't know, see out d dot begin. I don't know. I just want to see what's inside D, so. I could just print out D. Okay. I just want to see what it is. Okay, so here, this ideally should be compared to by doing greatest least. So sort by decreasing. Okay, so here. Okay, so what did it give us? No, this is increasing. Crap. Okay. So this is increasing order. So here instead pair 1, 2 is supposed to be first is greater. Okay, so this is good. This does greater. Okay, so 1 dot first greater than 2 dot first does the greatest first value first. All right, now we're gonna do and the difference between crap. Okay, the difference between the first and the second. The two values, so the difference between that. If it's greater, do I want a greater first? Yeah. Okay, so the difference between those two values is greater, then this is going to be the second one, 2 dot second. Yeah. So this one's going to do the second. Basically, I'm sorting by the differences between these two values. So 7, 4, 10, 8, 3, 1, 5, 4. Okay, ideally this should work, but I don't know. I'm not 100% sure because what am I? I'm not 100% sure on comparators. Okay. 10.8.7.4.3.1.5.4. What? Wait, is that correct? Ten eight seven four 3.1.5.4. Is that what we said? 10.8.7.4 3.1.5.4. So no, we actually did 7.4 first because that's greater. So we actually should put this first. We should actually put this first. And then do that? Is that how it works? I don't know how comparator works actually. No, don't do this to me. Someone, please. Still 10.8.7.4.3.5.1.4. Actually, let's get rid of this. Now let's see what happens. We got 7.4, 10.8, 3.1, 5.4. Okay, so now we have the greatest differences. So for those ones, I'm going to pick the smallest value first. And I add that up with the total sum. And if it is less than m, then we keep it. Otherwise, we continue. And then until we get to the end, then yeah. So here from here on, I'm going to pick the smallest value first. So I'm going to do current sum is going to equal total sum, right? And then yeah, okay. So actually, we don't even need current total sum. We just use total sum. Okay. Now what we're going to do is we are going to pick total sum subtract by d at I dot first, and then total sum add by di add dot second. And if this is the case, is less than or equal to m, then we break. So here we need to have like sizes of our subset. Size is 0, right? Size is plus, then we break. Else we just have to actually else size is plus. So hold up. Yeah, here we just break. Total sum is greater less than your else size is plus, and we continue. In the end, we just print out sizes. Yeah, okay, so if size is equal to if total sum is less than or equal to crap. So at the end, if total sum is greater than m, then we print -1. Otherwise, we print out sizes. Okay. Let's see if this works. I'm not 100% sure though. Not 100% sure. Anybody watching the live stream? 4 people. We got something. Better than 1. If you're watching the live stream, say hi. Anyone? Okay, I'm gonna write hi in the chat. Hi guys. Anyone watching? Hello? 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 It needed conversational skills. Okay, why is it 1? Oh, size is plus plus before you break. Because I added this current one. Okay, so let's see if this works. Come on. 2. Okay, so that's right. Okay, let's see if this works. If this doesn't work, I don't know what I'm going to do. Cry? Actually, I don't think I want to cry. But I hope this does work, though. Yes! That's what I'm talking about, guys. Hell yeah. All right. So that's enough for today. We solved 2 problems. But yeah, that was just crazy. We got this to work. And this was an ad hoc problem. I suck at ad hoc problems. But yeah, it's crazy. We got this to work. I can't believe it. I mean, this is amazing. This is amazing. Yeah. All right, guys. Rate, comment, subscribe. No one's in the chat meant talking. If anyone wants to say something before I leave, please say something. I mean, there's 3 people watching, so 4 people actually. But I mean, if anyone wants to say something, you guys don't want to say anything. No one wants to say anything. Hello. All right. I guess I'm by myself then. Rate, comment, subscribe. I'll check you guys later. Peace out, though. Yeah, we solved this problem. This is amazing. But yeah, peace out. Chill. Yep. Beep, bop, boop.